focus today is called the changing weight. And the problem is, why does the weight change that way? I'm going to be weighing this object. It's a big fishing sinker, and I'm going to be weighing it in 4 different jars that have different fluids in them. Okay, and it'll have a different weight in each jar, and that's because of the manipulated variable, which is your task to find out about. But I'm going to weigh this in units called nails, these little nails. Okay, now this is a homemade balance scale. See, it's got a fulcrum here. We had the word fulcrum in an earlier focus. Okay, I know that this weighs about 600 nails, the equivalent of 600, about a little less than 600 nails. Okay, well, I have to put the counterweight in here and then see how many it takes to make this go down. But I didn't want to count out 600 nails every time. So what I did was I made a counterweight that's equal to 600 nails. This is a plastic bag with nuts and bolts and sinkers in it. And that's equivalent to 600 nails. So that way I don't have to count out 600 every time I do this activity. Okay. Now, some of you can't see it, but there's a nail over here to hang the sinker on. And if this is working okay, it shouldn't go down yet. Okay. Now, I'm going to rely on you to tell me when it goes down. I think I better put it up here a little bit more. I'm going to rely on you to tell me when it goes down, because I'll be so busy counting nails I might not notice that it goes down. Okay, now I have these 4 jars here, but I'm not going to let you see yet what is in them. But first I'm going to weigh it in jar A. I will tell you this much. They all have, each one has some kind of fluid. But remember the definition of fluid. A fluid can be either a liquid or a gas. A fluid can't be solid. So either liquid or gas. Okay, now I'm going to put the sinker in jar A. And then I'm going to count how many nails it takes to make it go down. Be sure you let me know when it goes down, because I may not notice. 1, it'll take several. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, wow, I only took 11. Okay, well now here's what we're going to do. This is actually I'm using this as a reverse scale. I know that the counterweight is 600. So what I'm going to do is subtract the number of nails each time. Now how many did I put in there? 11? 11? Okay, so the weight in A is 600 minus 11, which would be 589. Okay, that's the weight in nail units. Instead of using ounces or pounds, I'm going to be using nails. You can use any units you want as long as they're all the same. Okay, now I'm going to weigh it in jar B. Okay, you can tell now that it weighs less because the end hasn't gone down. So it weighs less than jar B. Okay, so I'll continue counting. 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, I'm gonna run out of nails, 55, 56, 57, 58, 59, 60, 61, 62, 63, 63. Okay, so now it's 600 minus 63. So it's 537. Is it 500? No, not 537. 63. Yeah, it's 537. Right?
Yeah.
Okay, well, it's the same sinker, but now it weighs less than in the fluid in jar B. Okay, now I'm going to weigh it in jar C. Is it lighter now? How can you tell it's lighter? Because the end hasn't gone down. Okay. Okay. All right. So we got 63, 64, 65, 66, 67.
67.
600 minus 67.
536.
533. Same sinker, less weight. Okay. Now we'll do it in jar D. Does it weigh less?
Yeah.
How do you know it weighs less?
Because
Because it hasn't gone down. Okay, let's see how much less it weighs. That was 67, 68, 69, 70, 71, 72, 73, 74.
74.
526. Okay, I can erase this now because I don't need that anymore. That was just for my calculation. All right, so when the problem says, why does the weight change that way? It means, why did it weigh most, or least here, or what, it weighed most here, 589. It went down and down and down, and it weighed the least here. So your task is to figure out why the weight changed that way. All right, now, already, without gathering any data, somebody should be able to give me one word that describes the manipulated variable. What's the manipulated variable, Jeremy? Fluid. Remember, fluids are gases and liquids, but not solids. There are only three states of matter: solid, liquid, and gas. Fluids include gases and liquids. Okay, so what do we need to find out in order to answer that question? Who can tell me something we need to find out? What general thing do we need to find out? Emily? What the fluids are. Okay, so let's just take them in alphabetical order. Does A contain blank? Yes. All right, here's some clues about A. It's a gas. A is a gas. It's not a liquid. It's a clear, colorless gas. It is actually a gas that's composed of a mixture of three other gases: 70% nitrogen, 29% oxygen, and 1% carbon dioxide. Who knows what the mixture is? Emily B?
It's so different in oils. They're not different.
Who knows what mixture of gases is 70% nitrogen, 29% oxygen, and 1% carbon dioxide? Tanner?
Helium.
No. Helium is a pure gas. Darby? Air. A contains air.
So A contains nothing?
There's the air. Amazing but true. Okay? All right. 2. Does B contain blank? Yes.
But it does for
All right, now, here's some clues about what's in B. It's a liquid. It's a clear, colorless liquid. I'm going to show you B. Here's B. Clear, colorless liquid. Well, how many clear, colorless liquids are there in the world? Several hundred? Hey, we have to narrow it down more than several hundred. What do we have to narrow it down to before you guess? 1 clear, colorless liquid. All right. Now, this is something you might remember from the previous focus. If you drank this, you'd be dead in an hour. Who knows what it is, Allie? Rubbing alcohol. I'm just going to put alcohol because all alcohols would have the same effect on the weight. Okay, so that's alcohol. Okay, 3. Does C contain
Something.
blank? Yes.
I don't remember.
All right.
It does.
Here's C,
Oh, wow.
a clear, colorless liquid. Brand. We've narrowed it down to 10,000. Clear, colorless liquid. Okay, here's a clue. It's the liquid that we program our space probes to look for on other planets. What is it, Darby?
Water.
Water. Why? Who can tell the class why we look for water on other planets? What's the reason?
Because if there's water, there might be life.
There might be life. If there's water, there might be life. Right. Okay. So that's C. All right. Water. I can start labeling these here. I guess I'll have to kind of slap my labeling. That's air. That's alcohol. That's water. Okay. 4. Does D contain any? Oh, not any. We don't need. It's a pure substance, so we don't need the word any. Does D contain blank? Yes. Tanner, how could you know what it is? You don't have a clue yet. All right. I'm going to show it to you. I've got it. You got to lift the sinker out because the sinker was in it. Okay. Clear, slightly yellow liquid. Clear, slightly yellow liquid. All right. This liquid is usually found in the bathroom, but it's also found in the kitchen. It's usually found under the sink in the bathroom. It's usually found under the sink in the kitchen. Clear, yellow liquid found under the sink in the bathroom and the kitchen. What could it be, Chase?
Bleach?
Well, it could be bleach, but it's not. Jeremy?
Lysol?
Lysol could be, but it isn't. Okay, look, I'm going to draw, I'm assuming you have this copy. I'm assuming you have this copy. So I'm going to draw something over here, and I want you to tell me what I'm drawing. This will give you a clue about what D is. Clear, yellow, liquid found under the sink in the bathroom and the kitchen. Now tell me what I'm drawing. I'm going to use black for this. Okay.
Oh, it looks like a pound. I see. Yeah, it is a sink. That's underneath the sink.
Title of the sink.
Under the sink. A cactus?
That is a sink full of water. Why is it full of water? Why is it full of water, Emily?
Because they just wash their hands.
Because what?
They just wash their hands.
No.
Just plug in
It's
dishes.
clogged. It's clogged.
Oh.
There's a clog down here. Here's where the clogs usually occur, right here, see? If there's a clog in the bathroom drain, it's usually from hair, because a lot of people comb their hair over the bathroom drain. If it's in the kitchen drain, it's usually from grease, because a lot of people pour their bacon grease and other kinds of grease down the drain. Both hair and grease can clog that drain. All right, now, here's what you do. You get a bottle of this liquid, this fluid D that I'm talking about. You get it at the store. Oops, I didn't draw that very well. Still didn't draw it very well. Okay. You pour it out and it goes down here. And it dissolves the hair or the grease. Who knows what it is now? Anybody know what it's called? What do you think it's called, Janelle?
Bam.
No.
There's spam.
Brenda?
So,
No. Nobody knows? Jeremy? No.
I mean, yeah.
What, Jonathan?
magic.
No, it's got this many letters in it. D, R, A, N, O. Drano,
Never heard of it.
also called liquid plumber. Also called, they're the same. They're the same. They just have different names. Okay. Drano is designed to dissolve protein and fat. Hair is protein and grease is fat. It's designed specifically to dissolve protein and fat. All right, now, you're going to notice after I finish this activity and put everything away, I'm going to go over and make sure I wash my hands. Why? Why?
If you touch your like some people touch the inside of your mouth, it could dissolve your tongue.
No, Chip, who can tell me what your skin is composed of? What two things is your skin composed of? What, Jacob? No. What? Fat and protein. Your skin is composed of fat and protein. Why should you wash this off if you get it on your skin? Otherwise, what'll it do, Emily? It'll dissolve your skin. Okay. All right. Now, here's just a kind of a matter of supplementary interest. This part right here is called the trap, and that's always full of water. That's required on all drains in Pierce County.